Hello, we're going to finish the female reproductive system. We're almost there. We now understand how the cycle of the ovary occurs, but now to understand the full menstrual cycle, we've got to understand what happens with the uterus. So that's what we're going to start to talk about. First, we're going to just talk about the ovarian cycle a little bit more, where we see the different phases of the follicle in the ovary, as well as the different amounts of estrogen, progesterone, luteinizing hormone, and follicle-stimulating hormone that occur throughout the cycle. The menstrual cycle is going to start with menstruation, the first day of menstruation, because that's the only day when it's obvious where you are in the cycle. So that's day one of the cycle. We're going to, at the beginning of the menstrual cycle, have just a small increase in FSH and luteinizing hormone. That is going to cause the follicular phase of the cycle, which is when the follicle starts to mature or continues to mature. Remember, the first part is not dependent on GnRH or LH or FSH. It's the second part of maturation. So that's what's going to start because we have a little bit of an increase in LH and FSH. We're going to have our follicles maturing, making more and more estrogen. We're going to have our chosen follicle making a lot of estrogen, enough to now have a small decrease in LH and FSH production that's going to kill the other follicles. And then finally, we're going to have the maturing follicle large enough that it produces this large, rapid increase in estrogen that acts on that second group of kisspeptin neurons to cause the LH surge. So that's what's shown in green right here, this LH surge, which triggers ovulation, the release of the egg, and causes corpus luteum formation, where the granulosa cells and theca cells that remain are going to continue to make estrogen, as shown right here, but then also increase dramatically the amount of progesterone made. That will continue for a certain amount of time until eventually the corpus luteum is going to degenerate. And when it does that, it's going to stop producing its hormones, and estrogen and progesterone will fall dramatically. If they fall, or when they fall, and decrease in levels, then that allows a small increase in FSH and LH levels, which is what we said happened at the beginning of the cycle to start another round of follicles to mature. So that's what happens at the end, and that's why at the beginning of the cycle we have this small increase in FSH and LH, which causes a whole other cohort of follicles to start to mature because the corpus luteum just degenerated, which means estrogen and progesterone levels fell, GnRH went up. Now let's add in the uterus, so we are looking at the same figure, it's just we've added the uterus to the bottom of the figure, where we said we're going to have this drop in LH drop in estrogen and progesterone, because the corpus luteum says, okay, we didn't get pregnant, we'll have to try again next time, we'll degenerate. And as a result of that drop in estrogen and progesterone, remember the ovary is controlling the uterus. So it's that drop in estrogen and progesterone that is the signal, okay, we didn't get pregnant, uterus, you need to start with a clean slate, almost literally. And so menstruation happens when the lining of the uterus sloughs off. So that's what's happening for roughly the first week of the cycle, is that we didn't get pregnant, the corpus luteum degenerates, estrogen and progesterone fall. That's the signal to the uterus it's time for menstruation. And so the lining of the uterus, which is what's shown in this bottom figure, sloughs off during menstruation. Then during the follicular phase, or later during the follicular phase, we've got this increase in estrogen coming from the chosen follicle. So estrogen by itself will cause the proliferative phase of the uterus, where now menstruation has occurred and we need to build back up the lining of the uterus. And so the estrogen coming from the chosen follicle is what causes that proliferative phase of the uterus so that it can build itself back up. Then in the second half, in the luteal phase, when we've got the corpus luteum active, we've got estrogen and progesterone. That causes the secretory phase of the uterus, where it's still proliferating, it's still getting taller, as you can see in the diagram, but it's also starting to secrete substances. So basically, the lining of the uterus is getting ready to possibly receive a forming embryo. So the estrogen and very specifically the progesterone are going to be needed to put the uterus into the secretory phase to begin the final stages of preparing for the implantation of an embryo. So that will continue until, if there is no pregnancy, the degeneration of the corpus luteum and sloughing off and menstruation all over again. So you can see how the hypothalamus and pituitary are controlling the ovary, and the ovary is what is controlling the uterus and determining what phase it's in. So what happens if we do have a pregnancy? Then the embryo that is going to be starting to implant in the uterus that has been prepared because of the secretion of estrogen and progesterone, the embryo will make a hormone called human chorionic gonadotropin, or HCG, which is very similar to LH. It's going to bind LH receptors. And remember, LH is what formed the corpus luteum. And so HCG will bind those receptors and maintain the corpus luteum. It will remain to produce estrogen and progesterone. And if estrogen and progesterone remain elevated, then the uterus is going to remain in the secretory state. We're not going to have menstruation, and GnRH levels are going to remain low as well. So we will not start a new cycle as long as we've got HCG being produced, which maintains the corpus luteum, maintains estrogen and progesterone, so we don't have menstruation and GnRH remains low. HCG is what will spill out into the urine and is what is measured in an at-home urine pregnancy test, or it can also obviously be measured in the blood. And we'll see in this slide how HCG levels rise dramatically at the beginning stages of pregnancy. So these are hormone levels at different months of pregnancy, and you can see 0 is going to be the first day of menstruation. So about a month when finally the embryo is implanting and now really making lots of HCG, you can see how dramatically it increases. And then it also dramatically decreases at about the end of the first trimester, at 3 months pregnancy, because, and as a result of HCG no longer being produced, the corpus luteum will now start to degenerate. So instead of degenerating at the end of the menstrual cycle, it's now degenerating at the end of the first trimester, so that the estrogen and progesterone will no longer be coming from the corpus luteum. That's okay. You can see estrogen and progesterone levels continue to rise throughout pregnancy, because now out here it's starting to be made by the placenta. And so at the end of that first trimester, there's a shift from estrogen and progesterone being made by the corpus luteum to it being made by the placenta, until at delivery, when we're going to have a rapid decrease in both hormones with delivery of the baby. Let's go back to thinking about some of our estrogen responsive tissues like, or estrogen and progesterone responsive tissues like the uterus, and the characteristics of estrogen and progesterone. So remember we said that estrogen alone is going to make the uterus be in the proliferative phase where it needs to build back up. That's going to be in the first half of the menstrual cycle. And when this happens and we have estrogen by itself, it acts to increase its own receptor. So again, it's going to be this positive feedback action where you have estrogen, it's going to cause an increase in the number of estrogen receptors, which means the tissue is more sensitive to estrogen. It's also, estrogen is also going to increase the number of progesterone receptors, which we call a process called priming, because at the time we don't have progesterone around, but soon, once the corpus luteum forms, we will. And so it's getting the tissue ready so that it'll be nice and sensitive to progesterone once progesterone is made. And so in this way, estrogen acts to cause proliferation rapidly by making the tissue more and more sensitive to it. And then it also prepares it for progesterone, which by causing expression of progesterone receptors. Now, you need to stop this somehow because you don't want to keep proliferating. And so progesterone is going to be important because it's going to act to reduce the number of estrogen receptors to stop that process, since we have this positive feedback of estrogen increasing the number of estrogen receptors. Progesterone is going to stop that by decreasing the number of estrogen receptors. So this shows why giving estrogen only can be possibly cause something like cancer of the uterus, of the lining of the uterus, if it's without opposition from progesterone. If you have estrogen by itself, that can be a dangerous thing in terms of cancer of certain tissues like the uterus, which are estrogen responsive. You need to have some progesterone around to decrease the number of estrogen receptors. Let's move now to talking about oral contraceptives, where we are going to reduce the amount of GnRH in order to prevent pregnancy. The first birth controls were widely produced in the early 1960s. The first one was called Inovid, and it was composed mostly of progesterone with a little bit of estrogen. The estrogen originally was there as a contaminant, but once they realized that and then took it out, they realized that to have a little bit of estrogen there was good in terms of some of the side effects it prevented. So the pills were mostly progesterone with a little estrogen, but the progesterone will reduce the amount of GnRH produced and will prevent the LH surge. In the 1980s, there was a big change with birth control pills because they started to be made with synthetic hormones, which allowed them to be much smaller doses of hormones because they had a much higher half-life. So these pills in the 80s had 10 to 20-fold lower levels of hormones than the earlier pills and caused fewer side effects as a result. So birth control pills, as I said, are going to act to keep GnRH low. It's going to act to prevent ovulation by preventing the LH surge, but they also have other effects that are also very important as well in preventing pregnancy. One is to alter the mucus in the cervix, which is the first part of the uterus, that makes the mucus sticky so that sperm can't enter the uterus. So that's another very important effect of the birth control pills. And then there are also other changes in the uterus and oviduct that make pregnancy less likely as well. So it's just an important illustration of basically the negative feedback nature of the system, just like we've seen with so many of these hormonal regulation or regulatory systems in the body, where if you add extra hormone, you're going to depress the axis. So we've talked about now, we've got the follicular phase where we're going to have the uterus in the proliferative phase because we're producing estrogen. And then in the luteal phase, when we've got the corpus luteum making estrogen and progesterone, then the uterus is going to be in the secretory phase so that it's ready for implantation of an embryo. If we do have implantation, then we're going to have HCG from the embryo, which is going to act very similarly to LH to maintain the corpus luteum. That's going to last for the first 3 months. But then after the first trimester, the corpus luteum is going to degenerate. And because HCG levels are going to fall, that's okay because the placenta is going to take over producing estrogen and progesterone. And then we finished up talking about how oral contraceptives are going to reduce LH and FSH release by repressing the HP axis.